All right, so section 6.6, we're going to be looking at the fundamental theorem of calculus. Now, just like the name states, it is fundamental for calculus. It's very important. And if you're like me, then whenever you hear the word fundamental, you think of this. So let me show you this clip real quick. It doesn't really have anything to do with calculus. It's just what I think of when I hear the word fundamental.
The fundamentals of business. The fundamentals of business. Mental is a part of the word. I have underlined it. Because you're mental, if you don't have a good time, you have to enjoy it.
Well, the fun is in it.
Fundamental.
Oh, right.
Get out. Yes, so...
Okay, so basically, you would be mental if you didn't think this was fun. I mean, it's calculus, so it's going to be fun. But anyway, the fundamental theorem of calculus basically states this. So go ahead and write that down. If f is continuous on the interval from a to b, and a capital F, remember that is our notation for a antiderivative, is so if f, capital F, is any antiderivative of f on the interval from a to b, then basically what we do is we take the integral of that function, and then once we have that, we will plug in our values for a and b. So now basically we're going back to the definite integrals, okay? So we will do antiderivatives, but then we're going back to definite integrals. So we're doing indefinite by finding the general formula, and then we will plug in what these values are, whatever a and b are. Again, a has to be the smaller number on the bottom, so if it's not, you need to basically multiply by a negative to flip those. But we're going to spend some time in this section because, as the name states, it's fundamental for calculus, okay? And it's fun. So let's go ahead and do some examples. Now, the first thing we need to do is the antiderivative. So let's look at the antiderivative of 9 would be 9, oops, guess I need to have a pen, 9x minus the antiderivative of x squared would be x to the third divided by our new exponent, which is 3. Remember, add 1, divide by that number. Now, normally when we do antiderivatives, we would need a plus c, and I will show you in this first example why we don't need to have that anymore. So, the notation here is we put a little line, like a vertical line, and we go from 3 to 0. Which means I'm going to plug 3 in for x, and then minus plug in 0 for x. So let me jump down here to do that. So 9 times 3 minus 3 cubed over 3 plus c, I don't know what c is, minus, plug in 0. 9 times 0 minus 0 cubed over 3 plus c. Now look at this. Tell me why the c is not important when we do the antiderivative for definite integrals. Now this only works when you have numbers outside here, okay? So why does that not matter? And that's because here's a c, and then there's a minus c right here, so they will always, always, always cancel out. So if you are doing indefinite integrals, okay, with no numbers on your integrand, or no numbers on your integral symbol up here, you need the plus c. But as soon as we start putting numbers up here, and we're doing the fundamental theorem of calculus, it is no longer necessary to have the plus c. So I'm not going to write that anymore, but I did want to show you here why we don't need to write it, because I think it's important that you know why it's no longer necessary. So let's do a little bit of arithmetic here. 9 times 3 is 27. Minus 3 to the third is 27 divided by 3 is 9. And then this is 0, this is 0, so they're gone. So 27 minus 9 gives me a final answer of 18. So now let me just make the connection here for us so we can see exactly what this is asking. 9 minus x squared. Let's take this back to what we did at the beginning of the chapter when we looked at the function. 9 minus x squared means we have the x squared function shifted up to 9. Okay, so there it is, and it would look something like this. And we are looking at this from 0 to 3, right? So there's a 1 and a 2. Now, what did we just do? Well, we just found the area under the curve from 0 to 3, which before we estimated using rectangles, left, right, midpoint, or we used the trapezoid or something like that. You know, we estimated that using geometric formulas. And I had said before, like, so what happens when we don't have a geometric formula for this, and we have to kind of estimate at first, but now we can get the exact answer. So the exact area of this curve, between the curve and the x-axis, between 0 and 3, is 18. Okay, so that's what this integral, that's what the fundamental theorem of calculus is now allowing us to do, is finding the area under any curve. It no longer has to be a straight line or a quarter circle or a trapezoid or, you know, something that we know a formula for. It can be any kind of curve, and this is how we do it. So again, the more math you learn, the more you know, opportunities open up for you to be able to discover more things. So this is what we're doing now, is we're finding areas of kind of like irregular shapes, okay, which we didn't really have the ability to do until now. So let's do some more examples. Here we go. Integral from 0 to pi over 2 of cosine x. So we got to say, okay, what is the integral of cosine? And hopefully you are thinking sine, because if we take the derivative of sine, we get cosine. We're going to evaluate this from 0 to pi over 2. Plug them in. Top one goes first. Sine of pi over 2 minus sine of 0. Now think of this as like, you know, when we were doing like a slope, okay, and we did y2 minus y1 over your x's, x2 minus x1. And then we went into our average slope where we said f of b, oops, parentheses, minus f of a all over b minus a. These are all linked up. They're all coming from the same places, okay? So it's the function of the final minus the function of the initial, okay? A lot of times when we plug 0 in, we will end up getting a 0, probably like 80% of the time. But I can guarantee you that you will see one on the AP test where this does not give you a 0, and one of the answers will be what you get if this was a 0. So just be cautious of that, because it is something that they try to trick you on, and we know better, so we're going to take care of that. Sine of pi over 2, go back to trig, sine of pi over 2 is 1. Minus sine of 0 is 0. So my answer is 1. So what did I just do? Again, I like to draw a picture here for the first couple so we can see exactly what it is. So let's look at the graph of cosine. So starting at 0 is up here, and then pi, and then it goes down. Remember, it does one of these things. So here would be pi over 2. And again, like I said, what we did was we just found this area to be equal to 1. Next, go ahead, pause the video, try this one out, and see what you get for your answer before we do this together. Okay, so hopefully you did that and you are ready to check your answer. So remember, if this helps, rewrite it. Integral from 1 to 9 of x to the 1/2. I know for some of us that is very helpful to do it like that. Add 1 to your exponent, divide by that number. So x, add 1, so 1/2 plus 1 is 3/2, divided by that number, so 3 over 2, which we could also rewrite this as 2x to the 3 over 2 divided by 3. We will evaluate this from 1 to 9. You are certainly welcome to rewrite x to the 3/2 as the square root of x cubed if you would like, but it is not necessary. So 2, plug in 9. 9 to the 3/2 over 3 minus 2 times 1 to the 3/2 over 3. Let's see what we get here. Now, keep in mind that when we do exponents like this, it does not matter if we do the square root first or if we do the cubing first. certain cases it's easier to do one over the other. So I am going to do the squaring, or square rooting, sorry. So the square root of 9, walk with me here, square root of 9 is 3. 3 cubed is 27. So 2 times 27, we're going to divide all this by 3. Minus, over here, 1 raised to any power is 1, so that's just 2 times 1 over 3. Now, notice that they have a common denominator already, so don't be tempted to say, well, 3 goes into 27 9 times, so I have 18 minus 2/3. While that is correct, these are already written as a common denominator, so let's do 54 minus 2 over 3 to give us 52 over 3, which is the final correct answer that does not reduce. Okay, that is how your answers will be written. You're probably not going to see it written as like 17 1/3, even though that would be correct, but you won't see the answer written like that. You're not going to see mixed numbers. You'll see improper fractions, okay? So that is the correct answer there. And here we go. Again, let's rewrite this because this one kind of looks a little messy. So rewrite it. Go ahead, get a head start, pause the video, see what you can do, and come back and check your answer. All right, so integral from 4 to 9 of x squared times x to the 1/2. Multiply those exponents, and what do we get? I'm sorry, add the exponents. We multiply the bases. So add the exponents. 2 plus 1/2 gives us 2.5, or like I said, 5/2 is a better way of writing that, dx. Integral gives us x, add 1, 7 over 2, divide by that number, 7 over 2. Same thing as 2x, 7 over 2, divided by 7, evaluated from 4 up to 9. Now, when I'm looking at this, okay, I'm seeing 2 times 9 to the 7/2 over 7 minus 2 times 4 to the 7/2 over 7. Now, this one could be a little bit rough to go through by hand. But again, square root of 9 is 3, and then 3 to the 7th. 3 to the 7th power. So let's think about that for a second here. So if we go through our powers of 3, we'd have 3, and then 9, 27, 81. That's 4 times 5 would be 243 times 3 again. And you can see that this is a lot to do here. Okay, so what would that be? 729. One more time. 2187. It's a huge number, right? 2 times 2187, if I did that right, that's what we're going to get over 7. Okay? Now, 2 is a little bit easier and a little bit nicer to do. Like in the next problem there, we end up with, I'm sorry, not the next problem, the next part of this problem. Square root of 4 is 2, and then doing 2 to the 7th power is a little bit easier, a little bit nicer at least, because we can kind of just double the number, right? And just go from there. But anyway, 2 to the 7th gives you 128. So this would be 2 times 128 divided by 7. Okay? Now, even still, this is like something you would not be necessarily asked to do by hand. So what I want to do right now is show you the calculator way of doing this, okay? Like I said, we could still go through this and do this by hand and get an exact fraction, but I don't think that I have ever seen someone being asked to do 3 to the 7th power by hand. So let me show you how to do this on your calculator, and then we will verify our answer that we have down here, should we subtract those numbers. But let's see what we get here. All right, so this is how we do it using our calculator. We're going to hit the math button, and if you look down here at 9, it says FNINT. That's a function integral. So we're going to hit math and then press the number 9. It'll pull up your integral. Now, let's see, where did we go? 4 to 9. So 4, press over, it'll go up to the top. 9 over. Now, let's just enter the function exactly the way it looked from the beginning, okay? That way, we don't have to take any chances of us making a mistake in our work. So x squared times the square root of x dx, hit enter, and it will do it for you. Okay, now that is a decimal. We could do 588.286, or we can go math fraction. It will change it to a fraction, 4,118 over 7. Okay, so those would be your answers, either form, again, depending on whether it's calculator or not. Look at your multiple choice and see which way the answer is written. Okay? So that's how you do that on your calculator. Math 9 to get the function, to get to integrals. Or if you want to get to derivatives, we could go math 8, and you can enter a derivative in there, which I believe I showed you before, but if not, there it is. Okay? So here you go. There's some problems to try. Again, like I said, we'll be spending some time in the fundamental theorem of calculus, but here's some just some introduction problems to try using your indefinite integrals and then plugging in the numbers for f of b minus f of a, just getting used to that theorem. Okay, so if you have any questions, let me know.